All right, so today's webinar, What's New in Lighthouse Studio 9.6, we are going to be talking about word import, Bandit MaxDiff, and also an improvement to our choice simulator with the new genetic algorithm. So I'm going to turn it over to Zach, who is going to talk about awesome word import.
Great, thanks Megan. So let's get right into it. What is word import? Word import is a new feature we've added to Lighthouse Studio 9.6 that allows users to import questions directly from a Word document into Lighthouse Studio. Your questions, your response options, your lists, your skips, all can be defined in a Word document, and then with the click of a button, it becomes a Lighthouse Studio survey. Now, if you've already installed 9.6, you've likely seen this new button in your File menu, New Study from Word. Once you've created your Word document, all you'll have to do is click this button, select your Word document, and your study will be created before you. Now, I want to talk about how we'll go about creating these Word documents. And the key to how that all works are what we call tags. Tags are how question settings are defined in the Word document. Tags are expressed as text that appears between bracket characters. I've got two example tags here on this slide. This first example is a page break tag. You'll be able to place this anywhere in your Word document and it will add a page break to your study. The second example demonstrates how some tags will have two parts to them, separated by this colon character. This tag will say that we want to set the maximum, for example, for a numeric question, to the value 100. It's worth noting that tags are insensitive to casing and to formatting, so feel free to have them appear however you desire in your Word document. Now, we're not going to have time to go over all of the tags supported in Word import during this seminar. However, I would like to talk on just a simple example question that I think will help get you started. So the first thing we need to do is this question tag. We'll add this tag to the Word document, and this tells the software that this is the beginning of a new question. And the name we're going to give that question is brands. Next, we want to choose what type of question we're adding to our survey. I want this question to be a select. So I'm going to add this type : select tag to give my question that setting. As you can see on the right, many types are supported: selects, numerics, open ends, and so on. The core general interviewing question types are supported in Word. Now, Word import, like Lighthouse Studio, will default a select question to using radio buttons. What if I want this select question to use checkboxes? I can simply add this optional checkbox tag anywhere to my select question, and now the question will use checkboxes. Next up, let's add question tags to our select question. I want to ask respondents which of the following brands they use. To do so, all I have to do is add any plain text, anything that's not a token, not a tag, sorry, to the Word document. And finally, no select question would be complete without response options. We're going to add brand A, B, and C to our select question, and we tell Word that we want these to be response options by making them a list. I have chosen to use a bulleted list for this example. You can also use a numbered list if you prefer. Anything that Word thinks is a list will work. And now at this point, we have created a full functioning select question. You could use this as is. But before we stop, I want to show you a few additional things that you can add to this example question. First off, what if we want response options to allow a respondent to choose their own answer or a none of the above answer? All we have to do is add this other tag or this exclusive tag to our response options, and Lighthouse Studio will take care of the rest. Next, perhaps we don't want respondents to be required to answer this question. So all we have to do is add a required or a not required tag to explicitly tell word import which type of question we want this one to be. And last but not least, we want to be able to show these brands in different orders for each respondent. All we have to do is add this randomized tag, and the brands will be randomized for us. And I think this is some of the beauty of using word import. There are all of these tags that are at your disposal that you can use when you need them. You can choose to leave off and go with the default if you don't. Now, one final change I want to show with the example question is formatting. Any text that is bolded, italicized, or underlined in the Word document will keep that formatting once imported into Lighthouse Studio. Now, that covers the example question. As mentioned before, I can't show you everything that a word import is capable of during this webinar. We don't have enough time. However, after the webinar is complete, we'll be sending out a copy of this PowerPoint presentation. At the bottom of the PowerPoint, you'll find an appendix with all of the functionality supported in word import explained. In addition, if you've installed 9.6 and you go into Word Import's Help section, you can find a sample study created by Megan that demonstrates all of the great power behind word import. I think that just about wraps it up for me, Megan.
Awesome. Thanks, Zach. I think the real powerful factor behind word import is just making things more efficient as we live in this world of research needing to be done faster and quicker. So hopefully you find this new feature of Lighthouse Studio super helpful. Another wow factor, I think, of 9.6 is our implementation of Bandit MaxDiff. So just to refamiliarize yourself with MaxDiff, MaxDiff is an approach for measuring preferences typically for a list of items, and those items might be messages or advertising claims or different images or features and so on and so forth. In the example below, we have different dessert options. And we have respondents answer the most and least appealing dessert, or the best and worst, or the most likely to purchase, least likely to purchase options. And then from one click of a button, we actually figure out how respondents feel about multiple combinations, right? Because when somebody selects the chocolate layer cake as the dessert they're most likely to choose, we know that it's better than the coconut cream pie, the tiramisu, and the creme brulee. And when they tell us that the tiramisu is the least preferred, we know that it's worse than the coconut cream pie and the creme brulee. The only combination that we don't know about is how coconut cream pie compares to creme brulee. So you can see that MaxDiff is super powerful in helping us determine this rank order of each of the items that we tested, or this preference order. And even better, instead of just getting a rank, we actually get utility values that are ratio scaled. So we can say that a score of a 7 is twice as great as a score of a 3.5. But what if we have a really large list of items and we're only interested in the ones that are the best? So for example, and this happens to me quite often, is I have a client who comes to us with a list of maybe 100 plus items. And they really are just interested in understanding which ones are the best ones for the sample. You might be thinking, how can somebody get to a list of 100 items? But it's actually pretty easy if you think about maybe packaging solutions, right? You can come up with multiple ways to test different packages, or even the amount of effort that Google put into figuring out the exact blue color of their G, right? So they went through thousands of iterations. So you can see how it'd be very easy to get up to 100 items. But if we try to use the traditional MaxDiff approach of showing every item at least 3 times, we're really going to struggle, right? We either have to have an enormous amount of tasks per respondent or a very large sample size, or we can use a more sparse approach where we don't show every item 3 times. So the problem with traditional MaxDiff is that it really doesn't scale as we start to increase in the total number of items. And there's really a limit when it comes to how many items we can ask per respondent. For me, in a MaxDiff, I really don't like to go more than 15 tasks. I kind of like to stay around 12 to 14. That seems to be the sweet spot for me. And also, if you need stable individual level estimates, you really don't want to ask them so many screens that you start to get bad data. And you also want to make sure that they see each item at least once, so that it's a more sparse design. The other challenges with MaxDiff are that MaxDiff assumes that we care about every item equally. So when we create a design within Sawtooth software, we want to make sure that each item is shown an equal number of times. But really, we only care about identifying the best items, or what we'd call the stars, especially when we have a lot of them. And if we show each item an equal number of times, then we're spending a lot of time asking about the items that we care less about, and not, an equal amount of time asking about the items that we really care about. In addition, MaxDiff, in the sense of how it's programmed today in the traditional way, doesn't learn from past respondents. So we could get information as people start to take the survey and understand which items are outperforming others, and then maybe oversample on those best items. And that actually is exactly what Bandit MaxDiff does. With Bandit MaxDiff, we don't waste so much respondent time on those items that appear down lower in the list, and we focus more time on those appealing ones. And as we get more information from folks, as more sample continues to come in, we're in a much better position to kind of separate out the stars from the rest. Bandit MaxDiff is going to use the preferences from previous respondents so that future respondents see MaxDiff questions that really oversample on the topmost items. And the greatest part about this is that it's actually done on the fly using simple logic that Zach will show you here in a few minutes within Sawtooth software. You don't have to, stop the survey a couple of days in and then see which ones are the winners and then only put those in the design. It actually all happens automatically for you in 3 steps. We use a counting analysis based on prior respondents and some Thompson sampling, and then we put those into the MaxDiff survey. The other great part about Bandit MaxDiff is that if you're really focused on identifying those topmost items, you can save about 75% on data collection costs because you don't have to interview as many people as you would if you had to show every item equally 3 times. We've also increased our Lighthouse Studio subscription from 500 items all the way up to 2,000 items. So if you're currently a suite holder, you can now test up to 2,000 items in your MaxDiff, or if you were on the MaxDiff 500 subscription, you can now automatically test up to 2,000 items. Finally, within the background, we have to kind of help Bandit MaxDiff understand how it should function. So if you're studying a large number of items, typically this is around 60 or more, we don't want to bring all 60 items into the respondent's questionnaire, right? We really only want to bring a subset of items. So by default, we usually say 30 items is kind of that sweet spot for how many items should be chosen for each respondent. And then depending on how many items you have, we think that aggregate logit is probably going to be most effective if you have, let's say, 100 items and you're only using a subset of 30 items in your Bandit. But if you are using less than that, you might be able to get good HB estimates quite well. So that speaks to the second bullet in that you can actually also use Bandit if you have, say, 30 or fewer items. Because each item is going to be shown at least once for every respondent, and that's going to get us really good individual level estimates. So if you show every item, but in a bandit approach, you can still get good HB utilities. If you start to have more items than you would show every item to each respondent once, then you're probably more in a logit model than an HB model. Okay, and remember, back to when you first started learning about Sawtooth software, HB, hierarchical Bayes, is an individual level model, so we get utilities for each individual, versus the aggregate logit model, meaning we get one set of utilities for all, to describe all individuals. So I'm going to turn it over to Zach now, who is going to show us how to actually create our Bandit MaxDiff within Lighthouse Studio. So let me get to that there, and I will give you control.
Excellent. All right, so as we see here, Megan has already done me a favor and set up this predefined list of movies. The number of popular films, and we want to get an idea of which of these films are our respondents' favorites. However, the list is quite large. We don't want to show all of them. We want to take a bandit approach to tackling this task. So the first thing we're going to do is we're going to create a constructed list. Let's call this Movies Bandit. And this constructed list is going to use our predefined list as its parent. As for the constructed list instructions, this is where we use Bandit. We're going to call the new Bandit MaxDiff function. Now, the first parameter we need to put into this function is the name of our MaxDiff exercise. We haven't created this exercise yet, but let's just call it MXD for now, and we'll create that exercise shortly. The next thing we need to do is decide how many items we want respondents to see. How many items are in that subset Megan talked about for each respondent? Let's choose 30 for this exercise. Now we've created our, that's all we really had to do to create the Bandit MaxDiff instruction. However, as a bit of a technicality, we also need to do this. We need to add a set list length function after the Bandit MaxDiff. And that set list length function, we need to pass it the same value that we're using in the Bandit MaxDiff. This is all really a formality for the MaxDiff designer. It needs to be assured that there are going to be exactly 30 items in the exercise. So with that done, our constructed list is ready to go. Let's create our MaxDiff. All right. We'll be adding in a new MaxDiff. We'll be giving it the name we selected earlier in the constructed list. Now within here, we need to go into the item section, and we can select to use our constructed list from before. Now, finally, the last thing we need to do in the Design tab, we've got this additional field. In here, we need to put in that value 30 from earlier. This is the same number that we used in that set list length function. It's just a bit of a formality for the MaxDiff designer. Finally, we can input in the number of questions we want each respondent to see. We can do something like 12 now that we only have 30 items being seen per respondent, and we're all ready to go. Takes a minute to generate the design, but then Everything seems to be working just fine. We'll submit this. And there we go. We've just created our very first Bandit MaxDiff exercise. You could send this out to respondents as is, and you'd be seeing the great results from Bandit. However, before we go on, I'd like to show you a few additional features that Bandit is capable of that you can use. First one of those, remember Megan talked about the idea of stars and dogs, the top items and those less, down below underperforming items. And by default, Bandit MaxDiff will apply a 5-to-1 ratio between those. What I mean by that is that for every 5 good items a respondent sees, they'll be seeing 1 less good item. This gives us a good statistical assurity that the items that we think are bad, we still want to show them every once in a while just to make sure that they are still performing less good than the better items. However, there may be times in which you want to change this ratio from 5-to-1. For example, if you have respondents and you think the respondents are they're not going to be as consistent with one another, which items they think are good and which items they're going to think are not so good, you may want to lessen that ratio, show more of the bottom performing items so that we can be extra confident that those items are in fact not as well received. And the way we do that is with this optional third parameter for the Bandit MaxDiff function. So I'm going to add in the value 20 here. And now what this Bandit MaxDiff function is going to do is it says, add in 30 items. Of those 30 items, I want 20 of them to be the top items, which of course means that 10 items will be selected from the more bottom tier items. This gives us a 2-to-1 ratio. So now Bandit MaxDiff may not be going as quickly to determine the best items, but it's going to be more confident that the worst items are in fact the worst items. That covers it for that extra feature. There is one other cool tool I want to show you. I know some users who've tried out Bandit MaxDiff have special business requirements for their exercise. For example, you may want to run a Bandit MaxDiff, however, it may be a requirement that one of the items in the Bandit MaxDiff be shown to every respondent, because you want to make sure you get plenty of information for that particular item. So let's see how you can do that. I'm going to, before the Bandit MaxDiff function, insert in the add function. It's my bad. Don't want add sorted, just add. And then we're going to add in movies, comma 1. So now what this constructed list is going to do, it's going to always add the first item, the first movie from the predefined list, and then it's going to add items based off the Bandit approach. This is it's a pseudo Bandit study, mostly Bandit with a few special requirements. And this is one of the great powers that comes with Bandit MaxDiff being a constructed list function. Anything you can do in a constructed list, you can now do with Bandit MaxDiff. Now that about covers it for the special functionalities. There are a few more technicalities I want to cover before I let you go. The first one relates to segmentation. There may be a time where you're conducting a Bandit study and you know you're going to be collecting respondent data from 2 different groups of respondents, one from group A, one from group B. And you don't necessarily know that these 2 groups are going to have shared opinions about the items you're asking them about. The concern you might have is that if you run a single Bandit MaxDiff study and send both groups of respondents into it, you're not going to be able to get as clear an answer. Bandit isn't going to be able to determine as well which items are best because it's getting some conflicting information. For a situation like that, you may want to consider adding 2 Bandit MaxDiff exercises to your study, and now have each of them have, group A go into the first Bandit exercise and group B go into the second one. Now they aren't sort of tampering with Bandit's assumptions. Next, we should touch on offline surveys. Because Bandit MaxDiff uses the data from previous respondents, it's not going to be as powerful a tool if you're using offline surveys. Because offline surveys will only have the data currently collected on that device. So if you're running an offline survey study, Bandit MaxDiff may not be the tool you want to use. And one final thing, Bandit MaxDiff uses all data collected from any respondents who have taken the survey before the current respondent, which means that if you upload your study and then take it yourself, you don't want the data you collected while testing your uploaded survey to affect the real respondents. Because of that, it's important that before you actually give your survey out to real respondents, be sure to go into your admin module and reset your survey. This will totally wipe Bandit MaxDiff and it'll be ready to go for new respondents. And I think that just about covers it for me, Megan.
Great, thanks, Zach. I'm just going to take a quick look and see if we have any questions so far. So just one quick question about Bandit. If it's using the previous respondent answers, is it only based on completes, or will it also bring in information from maybe start not finish people? Whose information is it using?
The software uses information collected from completed respondents. The reason we do this is because with an incomplete respondent, it's still possible for them to go back and change their answers. We can't be confident that they've actually finished the study and given us their finalized data until they finish the study.
Perfect. Thanks, Zach. All right, and now let's just go through the rest of these slides. I don't think you missed anything. And let's see. We talked about the different levels of adaptivity. Again, if your goal is to identify the top few items for the sample, you should really employ the highest level of adaptivity to optimize Bandit MaxDiff's algorithm. The minute that you start to lessen the level of adaptivity, you're going to show more of those dogs versus the stars, and therefore, like Zach said, not be as confident in your top items. You still get great utilities from it, but you might not be able to separate them from each other as much as you would if you used a higher level of adaptivity. And again, just remember, reset your survey data like Zach said, just to make sure that your test data doesn't influence your actual data. And then the final note, there's also questions about sample size as well. So with Bandit MaxDiff, actually this question just came in, so perfect timing. For Bandit MaxDiff, you can actually achieve a really good hit rate of, if you're looking for those top 3 items, with only 250 people if you have around 120 items. If you want to know about just the top 10, and if those items fall in the top 10, instead of being as specific as the top 3, you can go as low as 160. So with Bandit MaxDiff, with around 100 items, we would recommend about 200 total completes. If you're up in the 300 items, you're probably closer to 1,000 completes. And so on and so forth. So feel free to check out the simulation study done by our very own Kenneth Fairchild and Brian Orm and Eric Schwartz from the University of Michigan to see a little bit more on that technique. But if you were to do the traditional approach to MaxDiff and show each item 3 times and had 120 items, you'd probably be up at a much higher sample size than you can get at it with Bandit MaxDiff. Great question. And Zach touched on the segments. A really good example there is if you have customers versus prospects. We have a lot of experience with people doing MaxDiffs on product roadmaps. Which features should I put next into my product? And sometimes customers feel differently than prospects do. And so maybe you want to appeal to both groups. That would be a really good example of when you would want to create two different Bandit exercises, one for customers and one for prospects. But if we're talking about something more demographically oriented and we're not entirely sure that they would operate differently, like maybe different age groups, it's probably not as necessary. All right, so the last feature of 9.6 that we're going to talk about today is genetic search. And genetic search is once you've created your HB utilities from your CBC or adaptive CBC module, you get to go into the choice simulator and you can search for the optimal combination of your product or service based on each individual level utilities. There are a couple algorithms already included in the choice simulator. The exhaustive algorithm, which is essentially exhaustive, right? It goes through all the possible combinations. But the exhaustive algorithm gets really long and arduous if your search space is large, right? So if you have 10 attributes with 5 levels each, you're talking about 10 million combinations that it has to search through. And that can just take a really long time. So usually with a larger search space, you'd move to a grid search, which is really fast. But the downfall of the grid search is that it's not guaranteed to find your global optimal solution. So in that same example of customers and prospects, when we're simulating what is the optimal product combination, if customers have a different opinion than prospects, the grid search might only find us the optimal product based on how your customers responded, right? Because it's a greedy algorithm and it finds a spot to climb up a hill and it gets to the top and it's satisfied. But it forgot about those prospects and what they would want. And that's why the genetic algorithm is so powerful. It's going to be faster than exhaustive, but not faster than grid. But it's also going to find a variety of near optimal solutions. So if you do have peaks to your optimization search, genetic algorithms should pick up on this. So let me talk to you a bit more about how genetic algorithms are done. The concept behind the genetic algorithm really comes out of the idea behind evolution and Darwin's survival of the fittest. And what we do is we create different products. And the way we create products is we configure their different levels, right? We call these levels chromosomes. And as all of these levels combine into one product, we call that an organism, okay? So keeping with this theory of Darwinism and evolution, we generate a pool of organisms, and we can do this within Sawtooth Software's Choice Simulator, either using random or targeted starting points. And then of that pool of organisms, we figure out who's the most fit, either based on utility or share, and then we choose those most fit organisms to then produce offspring, and offspring are going to be a combination of the parent organisms. And then we evaluate the offspring's fitness along with the parents, and we cull through the population and remove the least fit members, whether they're parents or offspring, and then continue to do this over and over again until we can no longer improve on our generation, essentially. So offspring are going to be formed by random crossover and mutation methods. So we have parent A, which is just this product defined by these 5 attributes and their levels. And parent B, again, defined by 5 attributes and their levels. And then we create an offspring from parents A and B that creates this crossover on attributes 1 through 4, and then a complete mutation on attribute 5, so something completely different. And then we allow them to kind of compete in a survival of the fittest until we figure out that the population can no longer improve. And that final population is essentially the winner from the genetic algorithm. So let me go into the choice simulator. And what you should be able to see now is if you are familiar with Lighthouse Studio, you now have access to the choice simulator. And this is our cruise example. So we have different destinations that people can go on cruises. We have different cruise lines. We have a different number of days that they can go on the cruise. They also can choose from different staterooms, whether it's an ocean view, an inside room, or a balcony. And then the ship's amenities, whether they have more amenities or less, as well as the price per person per day. So we can simulate how people would choose between these 4 options. And down below, we would get shares of preference. That would say 11% would choose the Mexican Riviera cruise from Carnival, and 23% would choose the Holland American cruise to Alaska, 42% would choose the Royal Caribbean to the Eastern Caribbean, and 24% would choose the Royal Caribbean to the Western Caribbean. Okay, now let's say my client is the Carnival Cruise Line. All right, so I am going to do a search on the optimal Carnival cruise to compete with this Alaskan Holland American cruise and these 2 Caribbean cruises from Royal Caribbean. So what I can do is I can use the range function within the choice simulator and say, okay, search through all of the possible 6 destinations. Okay, and in addition to that, I also want to search through all of the possible durations or number of days. I also want to search through the staterooms and the ship amenities. And because price is a continuous variable, I can actually search from $100 to $200, and I can tell it the increment that I want to search on. So I tested increments of $25, but let's just say for fun in this example, we're going to search on an increment of $10. Okay, so in my scenario settings, beneath range behavior, I have my 3 different search methods. So if I search based on exhaustive, I can click simulate, and it's going to run through all 1,980 combinations and tell me that the best combination is for Carnival to offer an Eastern Caribbean cruise for 8 days with the fancy balcony stateroom with more amenities at the lowest price point. Okay, so in order for them to get 46% a share in comparison to the other cruise lines, this is what they would have to do. This is searching on share of preference. You could also search on revenue and costs as well. Just to show you the grid search for fun, remember the grid search is going to have a starting point and just climb up to the very top of the hill, and hopefully it finds the same answer as the exhaustive. But again, we tell you, because it's not exhaustive, we're not guaranteed to find the optimal solution. But lucky for us, our data in this cruise example is only single peaked, and we can see that if we offer the Eastern Caribbean for the 8 days in the balcony stateroom with more amenities at $100, that is our optimal combination, which is the exact same as what the exhaustive search found. But again, you can imagine that if you have a really large search space, exhaustive isn't going to work great. And if you're worried that you might have multiple segments in your population that are looking for different things, then that's really when genetic search algorithms play an awesome role. So you can go to search and then genetic. And then we can click simulate, and it's going to create our initial populations using each individual's utilities so that it has kind of an informed starting point. So it knows that individual 1 really likes going to the Eastern Caribbean versus individual 2 really likes going here, and so on and so forth. And so it comes up with these smart starting points to come to an optimal solution. Now, again, it's still not guaranteed to find it like the exhaustive does. But if you look at these results, you can see that the Eastern Caribbean for 8 days, the balcony stateroom with more amenities for $100 is actually the best option, which matches also our grid search as well as our exhaustive search. But if we wanted to search on all of these different product profiles, we might want to use a genetic algorithm instead of exhaustive, or use a grid to start and then run a genetic algorithm. So that kind of brings us back to the PowerPoint slides in the sense that how should we go through this as a practitioner? So what we recommend is that you run the exhaustive search method if your number of attribute level combinations is feasible, right? So if you only have 5 attributes with 4 levels each, there's really no reason to run the genetic or the grid search, right? You can run through all 1,000 scenarios pretty quickly and be very confident that you found the optimal solution. But if exhaustive isn't feasible, we would recommend that you do a grid search and run through multiple passes. And if you're going to get the same answer every time, then it's likely that you found the global optimum. If not, you could go back to the domain and rerun the exhaustive search based on some of that information that you got from the grid search. So if it always said that the Eastern Caribbean was the best destination, then you could maybe filter down your total number of combinations and fix the destination to Eastern Caribbean, but search on maybe some of the other attributes, and your exhaustive search would be more feasible. After that, we would say, if you aren't getting the same answer from the grid search, then you really want to use the genetic search. And if the business goal is to consider multiple objectives, so what I had showed you was only searching on share of preference, but I mentioned you could also search based on revenue or cost, you can use the exhaustive or the genetic search algorithms to search on multiple objectives, such as maximizing both profit and share. So that's a really powerful tool as well. So that is all that I have about the search options in 9.6. Okay. So if you are still on an old version of the software, feel free to reach out. We would be happy to set you up with Lighthouse Studio 9.6. And feel free to reach out to Zachary or myself should you have any other additional questions. Zach, did you have anything to add before we close out?
I think I'm good.
All right, wonderful. Thank you, everybody, for joining us. We appreciate you taking the time today, and we really hope you enjoy 9.6. Take care.